Hi all, good evening. Welcome to the fourth edition of this session. Right. Just want to do a quick check to check out whether everyone is able to hear me. Is the audio clear? Is the video clear? I'm going to take a break from viewing this to going to the chat to check with someone who's going to confirm that they're able to hear everything. Just hold on for a minute. Hello, is the audio clear? I'm just, if one of you could confirm that it's all clear and good, then we can go ahead. Hello, is the audio clear? I'm just, if one of you could confirm that it's all clear and good, then we can go ahead. Hello, is the audio clear? Is it clear? Right, let's get started. Hi all, today we are going to be doing the second part of statistics and averages. Right, the focus today is going to be standard deviation and variance. Right, in the last session we looked at mean, median, range, and mode. This time we'll be focusing on standard deviation and variance. That basically completes all concepts we need to cover as far as this topic goes. Subsequently, we'll look at some practice for standard deviation and then wind the session with about 7 questions which are data sufficiency questions in statistics and averages. 5 of those are easy, 2 of those are medium level difficulty. So this is the basis for it. It's been raining quite heavily in Chennai today. I hope we are able to run this session without any interruption. Right? Let's get started. I'm going to be sharing the screen with you in exactly a minute. Here we go. We're going to be starting this standard deviation as follows. This is the structure of today's presentation as far as the concept behind standard deviation goes. We'll look at how to compute standard deviation. The how is very, very important because without that, knowing anything about it is of no meaning. Subsequently, we'll look at what is the standard deviation, what does it measure. Third, we're going to be looking at what is the effect of adding a K to each element in a data set on the standard deviation of the set. Fourth, the effect of multiplying a number, multiplication or division of a number to each element of the set on the standard deviation. And lastly, this is very, very important. What does it mean by lying within one standard deviation and how to solve questions of that kind? We'll start with this. We'll start with the how to compute the standard deviation. Computing the standard deviation, there are 2 methods to doing it. We'll start with the first method. The first method has got 5 steps. It actually is not 5 steps, but I've broken every single activity into a step. That's all is there to computing the standard deviation. The first step is to compute the mean, compute the average or the arithmetic mean of all the elements given to you for which we are finding out the standard deviation. Step 2 is computing the deviation. What is deviation? Pick each element in the set and find out how much is it deviating from the mean. So the element minus the mean is going to give you the deviation. This is step 1, computing mean. Step 2, computing deviation. Third step, we're going to be squaring the deviation because some of these deviations will be positive, some will be negative. So we're going to be squaring it to negate the effect of negative numbers. So squaring the deviation is the third step. Fourth step is going to give us what is called the variance. Variance is nothing but the average of the squared deviation. All the numbers that we are going to be getting in step 3, we're going to find out the average for it. That gives us the variance. The last step, the fifth one, is going to give us the standard deviation, which is nothing but the square root of the variance. So SD is equal to root variance. Variance is nothing but the squared deviation. Pick all of them, add them, find the average. That's going to give it to us. Right? So 5-step process. Let's get started with a very simple question. Find the standard deviation of 3, 9, 15, 21, and 27. Step 1, let's compute the mean. Sum of these quantities divided by the number of quantities. 3 plus 9, 12, plus 15, 27, plus 21, 48, plus 27, which is equal to 75. How many numbers do we have? 5 of them. 75 by 5 is equal to 15. Before we go to the second step, just want to impress upon certain things to you. Whenever you look at numbers, just spend another 5 seconds to figure out if you can get some additional information about these numbers. The numbers that you see here are all in an arithmetic progression. 9 minus 3 is a 6, 15 minus 9 is a 6, 21 minus 15 is a 6, 27 minus 21 is a 6. So the difference between any two consecutive terms is the same. So these set of numbers are in an arithmetic progression. For an arithmetic progression set, the middle number is always going to be the mean. I'm not telling you that all questions in GMAT are going to present you with an AP. But if you get a question which has got AP in it, then basically don't waste adding and computing this. Just pick the middle number and you have the answer. The only thing is you need to arrange them in an ascending order. So you found out the mean, either if you went about it this way or you spotted it. Let's move on to step 2. Step 2 is computing the deviation. The terms are 3, 9, 15, 21, and 27. And we computed the mean to be equal to 15. So deviation is 3 minus 15, which is equal to minus 12. 9 minus 15, which is equal to minus 6. 15 minus 15, which is equal to 0. 21 minus 15, which is equal to 6. And 27 minus 15, which is equal to 12. So we computed the deviations. Just step 2 done. Step 3 is squaring these deviations. Minus 12 square is a 144. Minus 6 square is a 36. 0 square is a 0. 6 square is a 36. And 12 square is a 144. So we computed the squares of the deviation. We squared the deviations. Step 4, we're going to compute the average of the squared deviation. 144 plus 36, 180. There is 180 here too. So together, the sum is going to be equal to 360 divided by how many numbers do we have? 5. So 360 by 5 is equal to 72. So this is your variance, or this is also called the average of the squared deviation. So this is step 4. The last step, step 5, is going to give us the answer. Standard deviation is nothing but square root of the variance, which is equal to root 72, which is approximately equal to 8.5. Quickly run you through these 5 steps in a printed form so we can recap it along the way. Computed the mean. The mean can be computed either by adding the quantities and dividing it by 5 if the numbers do not form any sequence. If it is in an arithmetic progression, spot the middle number and you have the answer. Next one, we're going to be computing the deviations. Deviations are minus 12, minus 6, 0, 6, and 12. Step 3, square the deviations. 144, 36, 36, and 144, this number being a 0. Now we're going to find out the variance, which is step 4, average of the squared deviation. Sum of the deviations is equal, squared deviation is 360 divided by 5 gives us an answer, which is 72, which is the variance. The last step is going to give us the standard deviation, which is square root of the variance. This is equal to 8.5. Get approximate numbers. One thing you can be guaranteed in the GMAT. GMAT is not going to test whether you can compute root 72 as an 8.483 or an 8.5. If you can say that it's somewhere between 8 and 9, that's good enough. Many a times your answer, final answer, is not going to depend on how closely you computed this. So do calculations only as much as is warranted. Don't go to the second or third decimal if it is not needed. Right? So gone through this. As I mentioned, this is method 1 of computing the standard deviation. Method 2, there is another method to compute the standard deviation. Know that method, pick the one that suits you. I'm not going to change the example. Let's stick to this example and compute it. The second method runs on this formula. Standard deviation is equal to mean of the squares minus square of the mean. Let's see how it works out. I'm going to start with the right-hand side of this, square of the mean. I'm going to start by computing the mean. The mean is equal to 15. Let's not even waste time. It's in an arithmetic progression. The middle term is the mean. We're going to square the mean, which is equal to 225. So we've got this part. The square of the mean is done and dusted. Let's get on to the first part. We need to find the mean of the squares. So we need the squares to start with. The squares of each of these numbers. 3 square is a 9. 9 square is an 81. 15 square is a 225. 21 square is a 441. And 27 square is a 729. We're going to compute the mean of this. So let's add all of these things. This divided by 5 should give us the answer. 9 plus 81 is a 90, plus 225 is a 315. 315 plus 41 is a 356, 756, 1456, 1497 is the 1487. Sorry, 1485 is the answer to this. This divided by 5 should give us this is the mean of the squares. We have found out the squares, we are finding out the mean. 1500 by 5 is a 300. 15 by 5 less than that, that's 3 less, which is going to give us an answer which is equal to 297. See, this part of the calculation is as painful as we did in the last method. So at some level, you have to do this calculation. You can't escape this. So compute this part also. Mean of the squares is equal to 297. Square of the mean is equal to 225. Under root this is going to give us the standard deviation. 297 minus 225 is a 72. So the answer is root 72, which is exactly what we got in the last method too. So whichever method you go about it, pick one. Practice with at least 3-4 questions so you know how to handle a question on computing the standard deviation. Quickly recap it in a printed form. Right. The method is mean of the squares minus square of the mean. We'll compute the mean. We found it out to be the middle term, which is 15. Square of the mean, 15 square, which is 225. Computing the mean of the squares, we squared all of these numbers, added them, divided it by 5, found out this value. The left-hand side term is equal to 297. Standard deviation is equal to 297 minus 225 under root of this, which is root 72 or 8.5. Right. I honestly, given a chance, go with the first method. I finished that. I don't bother to do the second method because sometimes computing this mean of the squares gets a little cumbersome. We'll get one more question to practice to hammer out how to go about it. I'm going to stick to method 1 to computing this. We're going to be computing the standard deviation of these 5 numbers. I'll just pause for 1 minute. You guys compute it, get the answer, and then we'll move on. Take a minute. Okay, guys, let's quickly run through it. It's a very easy set of numbers, right? Again, if you had spotted that these numbers are in an arithmetic progression, brilliant. So therefore, the mean is going to be equal to 15. We have done that, right? Done and dusted. Let's go on to computing the standard deviation. Step 2 is computing the deviation. 13 minus 15 is equal to minus 2. 14 minus 15 is a minus 1. 15 minus 15 is a 0. 16 minus 15 is a 1. 17 minus 15 is a 2. Square these deviations. Minus 2 square is a 4, minus 1 square is a 1, 0 square is a 0, 1 square is a 1, 2 square is a 4. So compute it, squares of the deviation. Let's set about finding out the sum of these and therefore computing the average. 4 plus 1 is a 5, 5 plus 5 is a 10. So sum of the squared deviation is 10 divided by 5, which is equal to 2. So this happens to be the variance. Let's go on to finding out the variance is 10 divided by 5, which is equal to 2. Standard deviation is square root of this, root 2, approximately equal to 1.4. If you know it's 1.4142, brilliant, but 1.4 will more than suffice. Quickly recap this entire thing in a printed form. So you know what we have done. Right? We computed the mean, 15. We computed the deviations, minus 2, minus 1, 0, 1, 2. Squared deviations, average of the squared deviations, which is the variance, which is 2. Standard deviation is equal to 1.4. Just doing this in a printed form every now and then. So like sometimes when my handwriting is not, you get another course to getting to the answer. Right? Now we got the standard deviation of the first example and the second example. We'll compare both these things and in the process understand what the standard deviation is all about. So we have understood how to go about it. We looked at 2 methods. We have done 2 examples to get confidence of cracking this in an examination. Let's understand what this stands for. Let's look at the first example and the second example. Compare those 2. The average for both these examples had been a 15. The first one, average is 15. Standard deviation, we computed it to be an 8.5, root 72. Second example, also the average is a 15. The standard deviation ended up being 1.4. Both sets of data have the same average, but different standard deviations. Here the standard deviation number is a larger number. Let's take a look at the data set. This 15 is a mean. Look at how very dispersed the data set is. We've had a number as low as 3 and a number as high as 27 in this data set for a mean of 15. Look at this data set. All numbers are hovering closer to the mean. The lowest number is a 13, the largest number is a 17. So what does the standard deviation actually measure? Standard deviation actually measures basically the extent to which the elements in a data set are dispersed. The elements are widely dispersed, then the standard deviation is going to be a higher number. If the elements are closer to the mean, then the standard deviation is going to be a lower number. That's why you see a higher standard deviation for the first set and the lower standard deviation for the second set. So if I have to define what standard deviation is, standard deviation essentially is a measure to find out by how much elements in a set are deviating or differing from the mean. It's actually a measure of the dispersion of a set of data from its mean. The more the elements are dispersed, higher the standard deviation. Lesser the dispersion, the standard deviation is going to be lower. Let's move on from here. Let's understand the third one. What happens when we add effect of addition on the standard deviation. Right. Go with this original example that we had, the second one, 13, 14, 15, 16, 17. Right. Our mean is equal to 15 and we went about computing the deviation, square deviation, standard deviation is root 2. I'm not going to take time on this. I'm going to look at another set of data. This example, the 5 numbers are 43, 44, 45, 46, 47. Let's compute the mean for it. The mean is the middle term because this is also in an arithmetic progression. Mean is 5. What are the deviations? Deviations are the same. 43 minus 45 is a minus 2. 44 minus 45 is a minus 1. 0, 1, 2. So it's the same as this, which means square of the deviations cannot be different, which means variance cannot be different, which means standard deviation also cannot be different. Look at this. All these numbers, 13, 14, 15, 16, 17. Compare it with 43. 43 is a 30 more than 13. 44 is a 30 more than 14. Each of the elements in set 2 is obtained by adding a 30 to the elements in the first set. Did we see any change in the standard deviation? Absolutely not. Because the standard deviation essentially measures the relative distance between these numbers. 13, 14, 15, 16, 17 or 43, 44, 45, 46, 47. Their relative distances have not changed at all. Therefore, the standard deviation is not going to change. So if I can produce this as a result, adding or subtracting a constant k to each term, you should be adding it to each term in a group. It does not have any impact on the standard deviation. But keep one thing in mind, the average was 15, average went up to 45. This is something we discussed in the last session too, which is recollecting here. If you add k to each element, the average goes up by a k, but the standard deviation remains unchanged. So we've done part 3, we've understood the effect of addition. Part 4 of this is the effect of multiplying. We'll keep this example 2 as is. So the standard deviation is root 2. All I'm going to do is I'm going to be multiplying each term of this set by a 2. So second set is 26, 28, 30, 32, 34. Is this in an AP? Obviously, yes. So the middle term is going to be our average, which is a 30. Let's compute the deviations in this case. 26 minus 30 is a minus 4. 28 minus 30, minus 2, 0, 2, 4. Just compare these two at this stage. You'll realize that the deviations have all doubled. Square the deviations. This is what we have. Variances 16 plus 4, 20 plus 20, 40 by 5, which is equal to 8. Standard deviation is root 8, which is nothing but 2 root 2. We multiplied each element of set 1 by a 2 to get the second one. The standard deviation of the first set is root 2. Standard deviation of the second set is going to be 2 root 2. So let's frame a result for it. If I multiply each term by a constant k, or if I divide each term by a constant k, you're going to be seeing the same effect both when it comes to our average. The average also doubled and the standard deviation also doubled. So addition or subtraction of a k has no impact on standard deviation. Multiplying or dividing it by a k will have the same effect on the standard deviation. Lastly, this is the most important part when it comes to solving questions in the GMAT. What does it mean by lying within one standard deviation? Let's say the mean of a group of elements is m and their standard deviation is d. You're saying lying within one standard deviation from the mean essentially means move one standard deviation to the left of the mean and move one standard deviation to the right of the mean. Anything that lies between mean minus deviation to mean plus deviation will be elements that lie in one standard deviation of the mean. What do you mean by lying within two standard deviations of the mean? You probably guessed it right. Mean minus 2d, mean plus 2d, whatever elements lie within this is lying within two standard deviation. Should it be integral number of standard deviations? Not necessary. You can move in 0.5 standard deviation, in which case what we'll say is mean minus 0.5d to mean plus 0.5d are the set of elements which lie within half a standard deviation of the mean. So many times you'll get questions, you'll say 40% of the data set lies within one standard deviation. Or you might be asked to compute how many data set elements in this data set lie within one standard deviation of the mean. So essentially, we looked at 5 concepts in this, right? We split it into 5. One, we started with how to compute. It's a 5-step process in method 1. Compute the mean, compute the deviation, step 2. Step 3, square the deviation. Step 4, compute the variance, which is nothing but average of the squared deviation. The last step is finding the standard deviation, which is square root of the variance. In method 2, we went about using this formula, under root mean of the squares minus square of the mean. So choose one of these two methods and practice at least 4 or 5 questions using that particular method. I don't want you to be dabbling with both because speed is of essence. You don't want to be wondering, is it like square of the mean minus mean of the squares or mean of the squares minus square of the mean? No such dilly-dallying in the examination. Right. Second, SD measures, what does it measure? The extent of dispersion of a data. Higher the dispersion, greater the value of standard deviation. Lower the dispersion, lower the value of standard deviation. Third, addition or subtraction of k to each element has no impact on the standard deviation. Fourth, multiplying or dividing by a k will have the same impact on the standard deviation. Lastly, we looked at what does it mean by lying within one standard deviation of the mean. If it's lying within one standard deviation of the mean, it's lying between mean minus deviation to mean plus deviation. That's what is lying within one standard deviation of the mean. Right? So basically run through the theory part of it. What we'll do is we'll do 2 problem questions which will focus on standard deviation. Basically gives you a flavor of how this topic gets tested in the GMAT. And then we'll run through 7 data sufficiency questions. All of those questions basically include things that you would have seen as part of standard deviation and also those that you would have seen in the last session. So this data sufficiency questions are not going to focus only on SD. They're going to focus on mean, median, mode, everything. Obviously, the easier ones will just focus on mean. The tougher ones, the more interesting ones will be focusing on other elements. Right? So just get set ready for the next 2 questions, problem solving questions in standard deviation. Right? When we stop sharing this, I'll start sharing the screen. Just one second before I open the next presentation. This is a good question, a typical question that you're likely to see. Consider the following set of numbers given as 50, 40, 10, 20, 60, 30, 70, 90, 80. So that has 9 elements in this set. How many of these observations lie in one standard deviation of the mean, the one that I said? So how are we going to go about it? I'll give you an indicator as to how to go about it. Take a minute or a minute and a half, compute it, come back, and then we'll discuss it. Right? The process that we are going to follow is compute the standard deviation because you need to find out what the standard deviation is, what the mean is as a process of it. Only then you'll be able to find out how many elements lie within one standard deviation of the mean. Right? We're going to be computing mean minus deviation to mean plus deviation. How many elements lie within that? So you need to know what D is. You need to know what M is. Take a minute, quickly run through this question, then we'll get started by discussing this. In the meantime, just step into the chat window to check out what's happening there. Did any of you get the answer? We'll just get started step by step. Let's start computing the standard deviation. The first step is to compute the mean. See, as a good practice, always, whenever you see numbers of this kind, write them in ascending order. It helps you find out if there is a pattern, right? The numbers are 10, 20, 30, 40, 50, 60, 70, 80, 90. These are the 9 numbers that we have. Obviously, they are all in an arithmetic progression. The middle number is going to be the mean. Let's not even waste time adding them and dividing them by 9. So mean has been computed. Step 2, let's basically compute the deviation of each of these terms from the mean. 10 minus 50 is a minus 40. 20 minus 50 minus 30. 30 minus 50 minus 20. 40 minus 50 minus 10. 50 minus 50, 0. 60 minus 50, 10. 70 minus 50, 20. 80 minus 50, 30. 90 minus 50, 40. So compute the deviations. Square the deviation. 1600, 900, 400, 100, 0. Again, it repeats 100, 400, 900, and 600. The beauty about having arithmetic progression, good chance you might get such a question too, is that once I've written whatever is to the left of the mean, the right of the mean is essentially be a mirror reflection of the same thing. Next step, you're going to be computing the variance. Variance is sum of all of these numbers divided by 9. 1600 plus 900 is 2500 plus 500, 3000 plus 3000. 6000 divided by 9 is going to be our variance, which is nothing but 666.66. How do I know that? 6 by 9 is a 2 by 3, which is 0.66 into 1000 is 666.66. The last step, let's compute the standard deviation. Standard deviation is square root of 666.66. This number, the face of it is daunting. 666 is actually Devil's number, right? But don't worry so much about it. 625 is the square of 25. 676 is the square of 26, right? You go with a 25 or a 26. If it makes a difference to your final answer, then let's compute it to a closer number. I'm going to say that this is approximately equal to 26. I'm going to an integer level approximation. Keep this in mind. No squares up to 50, no cubes up to 50. Questions such as this, you can crack them in a jiffy. Otherwise, you'll be wondering, how do I compute the square root of such a number? So standard deviation is at 26 for us right now. It's somewhere between 25 and 26, but I'm taking it as a 26, right? Is this okay? Now, the next step is basically to count the number of observations that lie within one standard deviation. The mean is 50. We have said the standard deviation is 26. So mean minus deviation is 50 minus 26. Mean plus deviation is a 50 plus 26. So 50 minus 26 is a 24. 50 plus 26 is a 26. So how many numbers lie between 24 and 76 in this data set? 30 lies in this set, 40 in this interval, 50 lies in this interval, 60 lies in this interval, and 70 does. So how many numbers? 1, 2, 3, 4, 5. So 5 numbers, 5 of these observations lie within one standard deviation of the mean. Look at it. If I had gone with the deviation to be at 25, I would have computed numbers between 25 and 75. Would the answer have changed? Absolutely not. So keep this thing in mind. Do calculations only as much as is warranted. Many a times we take more time to do calculation because we do more calculations than what is necessary. First question, done, dusted. It's more to the second one. It's a very interesting one. In fact, you're likely to get a question like the one we did the last, right, where you have to actually compute the standard deviation. But this is more likely to be a question that you're likely to see in the GMAT. Let's read this question. The standard deviation of 4 positive numbers, P, Q, R, and S, is D. They're given what the standard deviation is. What you need to compute is the standard deviation of 2P minus 2, 2Q minus 2, 2R minus 2, and 2S minus 2. You're going to be applying the properties that we learned and then get the answer. There's absolutely zilch calculation in this. Let's get started. What will be the standard deviation of 2P, 2Q, 2R, and 2S? P, Q, R, and S, the standard deviation is a D. We have obtained the second set by multiplying each element by a 2. If you multiply or divide each element by a K, the standard deviation is going to become K times that. We multiplied each element with a 2. So standard deviation of 2P, 2Q, 2R, 2S is going to be equal to 2D. But the question is not about 2P, 2Q, 2R, 2S. It's 2P minus 2, 2Q minus 2, 2R minus 2, 2S minus 2. We also seen this property. You add or subtract a k to each element, the standard deviation remains unchanged. We have picked 2p, 2q, 2r, 2s, whose standard deviation is 2d, and you subtracted a 2 from each of these elements. So will the standard deviation change? No, it's going to be the same as 2d. So that's all that you need to do. You probably would have taken 30 seconds to crack this question. Knowing this concept, knowing this principle of how the standard deviation behaves when subtracted or added or when multiplied or divided is what they're going to test. Right? The last question is intensive on calculation even by GMAT standards. This is how you're likely to see stuff. Right? So this puts an end to what kind of questions in problem solving you're likely to see. We'll get on to the more interesting one. Right? The men among the boys in quant section, which is data sufficiency. Start with the easier of the questions. Just give me a minute before I quickly swap this presentation. Before that, so key takeaway. Key takeaway is multiplication of each element of the set by a k will result in the standard deviation being k times. Right? Adding or subtracting will have no effect. We have told it umpteen times in this video itself. Just to recap it, so you never forget this. Right, these 5 questions are easy questions. You should probably look to solving each of them in a minute or a minute and a half. Let's get started. I'll go about it slowly. Now that you guys have the question, and probably my colleague Muthu has posted this a little while ago, get cracking on solving this. When I finish the basic components of it, we'll be getting into the statements, by which time you guys should have had the answer to this. What is the median of integers a, b, and c? Keep track of little things. The question says these are integers, right? So we need not bother about numbers being 1.2 or 2.3. They're integers, so they could be positive, they could be negative, they could also be 0. So have these little perspectives as you read questions, right? Statements have been given, but before we get on to reading the statements, let's understand when the data is sufficient. Whenever they say what is a median, we need to come up with a unique value. You need to come up with an answer that says the median of A, B, and C is equal to 8. The median of A, B, C is equal to 0. You need to come up with a value for it. This question is not asking, is A the median, B the median, or C the median, right? Get clarity on these things, right? Unless you have clarity on this, you might do everything right and get an answer incorrect because you've answered them wrong. Right? What's the approach? We're going to be evaluating each statement independently. Let's start with the first one. It says AB is equal to 0. We need to find out the median of these 3 numbers and we need to come up with a unique value for it. If AB equals 0, what are the possibilities? A could be 0, B need not be 0, A need not be 0, B could be 0, or both A and B could very well be 0. Do we have any information about C? We have no information about C. One good way of solving this question is look for a counterexample. Let's say A is equal to 3, B is equal to 0, right? This is one set. And let's say C is equal to 2. What is going to be the median? The median in this case is at 2. So we've got one value as 2. Can I run through the same thing as A is equal to 3, B is equal to 0, AB will be equal to 0, and C could be a value which is equal to 5. So what is going to be the median in this case? The middle number in this case is 3. So median is 3. Do we have a unique answer with this? We do not have. For a lot of questions, try and look for a counterexample. Because you haven't got a unique value using statement 1, statement 1 alone is not sufficient. The moment you rule out 1, rule out answer choices A and D. A says 1 alone is sufficient. D says the statements are independently sufficient. So what are we down to? We are down to 3 answer choices, B, C, or E. Start evaluating statement 2. Is BC equals 0? Exactly the same thing. There's no difference. In the last case, we had AB. Here we got BC. So B is equal to, let's say, a 3. C is equal to a 0. A is equal to a 5. What is the median? Median is equal to 3. B is equal to 0. C is equal to 10. A is equal to 9. What is the median in this case? Median is equal to 9. Do we have a unique answer for it? No. In both these cases, BC ended up being a 0. So because we have not got a unique answer with statement 2, 2 alone is also not sufficient, which means we can rule out choice B. Let's combine the 2 statements to decide whether it's C or E. Numbers are integers that's given in the question stem. AB equals 0, BC equals 0. So what is going to be the median? Again, just put down some numbers to check out what happens. All 3 of these numbers could have very well been a 0. In that case, AB will be a 0, BC will be a 0, the median is going to be equal to 0, right? I've got one answer for it. We look at another answer. Let's say this is a 3, B is equal to 0. Is AB equal to 0? Certainly yes. I'll put C is equal to a 5. Is BC equal to 0? Certainly yes. Are all these numbers integers? Certainly yes. What is the median in this case? We got a number 3. Just got two different values. There are infinite possibilities here. Despite combining the two statements, we haven't got a unique answer for the median. So choice C can be eliminated. E is the answer to this question, right? So the crucial thing I wanted to tell you with this question, a very simple question, get into the habit of looking for counterexample. Here is a structured way of looking for counterexample. Remember this acronym FNZI, right? FNZ is how we can remember it. F for fractions, right? Decimals, fractions will give you where a counterexample could possibly exist. Negative numbers, N, 0, and then finally integers. Because whenever we think about numbers, we always think about positive integers as numbers. Don't fall for that trap. Right. Let's move on to the second question. A little bit more interesting than the earlier one. If AB equals C, that's given in the question stem, what is the median of A, B, and C? Do we have any information about what kind of numbers A, B, and C are? The last question it mentioned integers. Here, no mention of it. So they could very well be integers, non-integers, negative numbers, anything is possible. Quickly check out when the data is sufficient. If you can find a unique answer again, because the question is, what is the median? Should be able to come up with an answer saying that the median is equal to 1. The median is equal to 0. If you get one value for it, then the data is sufficient. Start evaluating statements one by one. Question stem mentions AB equals C. We know from statement 1, A is equal to 1. Let's check it out. 1 into B is equal to C. So we have B is equal to C. Will we get a unique value for the median? If B is 10, then we'll essentially have 1, 10, 10. So what is the median? The median is 10. If B is equal to 5, the numbers are going to be 1, 5, 5. This corresponds to A, B, and C. So what is the median in this case? The median in this case is going to be equal to a 5. So with statement 1, you're not going to get a unique answer. Statement 1 alone is not sufficient. Let's rule out answer choices A and D with this. What we are down to is B or C, E. Let's evaluate statement 2 alone to check whether it's B. If not, let's combine the statements and decide whether it's C or E. Let's move on to statement 2. Here we have C is equal to 1. Question stem says AB equals C. So product of two numbers should be equal to 1. Could very well be half into 2 is equal to 1. In which case the numbers are half, 1, and 2. The median is equal to 1. It could have been a 1 by 3 into 3 is equal to 1. In which case the numbers are 1 by 3, 1, and 3. The median is 1. It looks like anything that we do, the median is going to be equal to 1. Right? So the temptation is to go with statement 2 alone would be sufficient. Did you guys evaluate negative numbers before you decided this? What if the numbers had been minus half into minus 2? Is this equal to 1? Certainly yes. What will be the ascending order of these numbers? Minus 2 is the smallest number, minus half is next, and then 1. So what would have been the median in that case? The median would have been a minus 1 by 2. So what I want to impress upon this, whenever you say a B equal to 1, we'll say that A is equal to 1 by B, and we'll always look for positive numbers. There are negative numbers which could spoil the broth for us. So here, statement 2 is not giving us a unique answer. It's giving us more than one possibility. 2 alone is not sufficient. Let's rule out answer choice B. What we are down to is choices C or E. Combine the two statements. We know AB equals C from the question stem. A is equal to 1 into B is equal to 1. What into 1 can give you a 1? It makes unless B is equal to 1. 1 into 1 is what will give you a 1. So A equals 1, B equals 1, C equals 1. What is the median? Median is equal to 1. We got a unique answer by combining the two statements. Statements together are sufficient. Choice C is the correct answer. Right? The key takeaway, do not overlook negative numbers and fractions. Right? Especially check out when you're thinking that there cannot be anything, just check out, can a negative number work? Can a fraction work? Right? That's what is going to make the difference. Let's move on to the third question. A little bit more interesting, right? We're getting into standard deviation. Set S comprises 4 elements, X, X, Y, and Z. We need to find out the standard deviation of set S. Again, we're asked to find out the standard deviation. the data is sufficient. When is it sufficient? When you're able to get a unique value. You should be able to say the standard deviation of these four numbers is equal to 1.8, is equal to root 92, is equal to 0. Come up with any one unique value, the data is sufficient. Let's start with each of these statements independently. Statement 1 says x equals y equals z. If all numbers are same, then their mean is going to be same. Let's say this is equal to a k. The mean is going to be k. So what is going to be the deviation? X is a k, mean is a k, deviation is going to be 0, 0, 0. Square of the deviation is going to be 0. So the standard deviation is going to be equal to 0. So we left it out to recall it in this case, which is essentially if all elements in a data set happen to be the same, then their standard deviation is equal to 0. Did we get a unique value with this statement? Certainly yes. Statement 1 alone is sufficient. If 1 alone is sufficient, our answer choice is going to be A or D. To decide this, let's evaluate statement 2. 2 says the product of these three numbers is a 0. It could very well be x, y, z. All three numbers could be 0, in which case the standard deviation will be 0. So the product of the three numbers is 0, standard deviation is 0. It could very well be a 10, 100 and a 0. The product will still be a 0. Standard deviation is not equal to 0. I don't even know what the standard deviation is, but we know it's not equal to 0. Do we have a unique answer with statement 2? Statement 2 alone is not sufficient. So we had two choices, A and D. Let's rule out D. Answer choice A is the correct answer to this question. What is the key takeaway? If all elements in a set are equal, then the standard deviation is 0. That's not it. If all elements are same, then the range of the data set is also 0. More important thing, the next one, these two hold good simultaneously. Essentially meaning that if the standard deviation equals 0, it means that the range is 0 and vice versa. Right? Shall we move on to the next one? This one is interesting because this includes concepts from rates and also from averages. Take a minute to read the question, try it, we'll solve it. I'll read the question while you guys are trying it. A stationary car starts moving and is accelerating constantly. Make a note of all these little things. Will it average higher than 60 km per hour over a 4 kilometer journey? This question, what kind of an answer will it fetch? It's a question that starts with a be verb. Anything that starts with is, will, do, does, all of these be verb questions, the answer to such questions is going to be an yes or a no. If you get a conclusive yes, data is sufficient. If you're able to say, yes, the average speed is going to be greater than 60 km per hour, data is sufficient. If you answer conclusively stating that, no, the average speed can never be greater than 60 km per hour over this 4 kilometer window, then the data is sufficient. When is the data not sufficient? If you say, with this information, there is a possibility that it could be more than 60, and there is a possibility that it will be less than 60, then the data is not sufficient. What data points that we have from this question stem? It's constantly accelerating. That's the most important point in this. And the total journey is for 4 kilometers, not for 4 hours. It's a typo here. Okay. Let's start with the first statement. The car travels the first 1 kilometer in 1.5 minutes. 1.5 minutes, we are looking at speed in kilometer per hour. Let's quickly convert this. 1.5 minutes into number of hours will be 1.5 by 60 hours, which is nothing but 1 by 40 of an hour. So what is the speed of the car? Speed is equal to distance divided by time. Distance is equal to 1 kilometer divided by 40th of an hour. So 40 goes to the numerator. The car is traveling at 40 km per hour when it has reached the first kilometer. The car travels 1 kilometer in this. So the average speed to cover the first kilometer is 40 km per hour. It's accelerating. So when it's accelerating, the speed is going to go beyond 40. But over the next 3 kilometers, is it going to average 60? That we do not know. It could very well do that. It need not do that. We have no idea about it. Therefore, statement 1 alone is not sufficient. Rule out 1. With that goes answer choices A and D. Look at statement 2 to decide whether it is B, or if not, let's combine and see whether it's C or E. Look at statement 2. The car travels the first 2 kilometers in 2 minutes. If it's traveling 2 kilometers in 2 minutes, the speed of the car is equal to 60 km per hour. If you travel on average a kilometer in a minute, then you're traveling 60 kilometers in 60 minutes. So 60 km per hour is the average speed for the first 2 kilometers. It's constantly accelerating. it has averaged 60 kilometers by the time it has reached 2 kilometers. So by the time it's going to reach 4 kilometers, because it's accelerating, the overall average has to be greater than 60. It's 60 at 2 kilometers. For next 2 kilometers, if it's accelerating, it definitely will be greater than 60, which is what we want. So it got a conclusive yes as an answer from statement 2. Statement 2 answered our question. Choice B is the correct answer. Right. Here, you need a little bit of rates concept to be able to answer this question. Let's move on to the next one. What is the standard deviation of 3 positive integers? They've said these are integers, A, B, and C, and they're positive integers. So this place, you don't need to worry about fractions, negative, none of that. Again, we need to find out a unique value. You need to be able to say the standard deviation is a 5, standard deviation is a 0. A number is needed to get to the answer. Evaluate statement 1. A minus B is equal to B minus C. Let's rewrite it. A plus C is equal to 2B. A plus C by 2 is equal to B is what it says. So A and C end up being the average. B ends up being the average of A and C. And the way these numbers are stacked, it essentially means that the gap between A and B is the same as the gap between B and C. Right? So essentially it points to the fact that C, B, and A are in an arithmetic progression. Look at it. A minus B, whatever is the gap, is the same as B minus C. So if the difference between any two consecutive terms is the same, then these numbers are in an arithmetic progression. The mean of that progression is equal to B. So we have found out that these terms are in an arithmetic progression. The ascending order of this progression is CBA. Descending order would be ABC. Doesn't matter whichever order it is. The numbers could very well be 5, 10, 15. The numbers could very well be 100, 200, 300. Are these in an arithmetic progression? Certainly yes. 15 minus 5 is equal to 10 minus 5. 300 minus 200 is the same as 200 minus 100. So A minus B is equal to B minus C. Standard deviation for this will be a different value, and standard deviation for this will be a different value. So statement 1 has not given us a conclusive single answer. Let's rule out choices A and D. What we are down to is B or C and D. Let's start by evaluating statement 2 alone to check whether it is B. Statement 2 says A is equal to C. Brilliant, but absolutely no information about B. So it could be a 4, 4, and a 4B, in which case the standard deviation will be a 0. Or it could be a 4, 4. These are values of A and C. And B could be a 40. Standard deviation is not equal to 0. No unique answer. I'm essentially looking for a counter example. So because we don't have a unique answer, statement 2 also can be trashed. Answer choice B goes down the bin. What we are down to is C or E. Combine the two statements. We know all these numbers are integers. A minus B is equal to B minus C. We said the ascending order of these numbers is C, B, and A. They are in an arithmetic progression. That much is known. Statement 2 says A is equal to C. The first and the last terms are same, and these numbers are in an arithmetic progression. The gap between this should be the same as the gap between this. We are saying the gap between these two numbers is a 0. That's possible only when B is also equal to A and C. So if B is equal to A is equal to C, which is when these numbers can be in an arithmetic progression, and the first and the last term of the progression can be the same. If all numbers are the same, what is the standard deviation? The standard deviation is a 0. Combining the two statements, we have a unique answer for the standard deviation. Choice C is the correct answer to the question. Here, slowly we have notched up the level of difficulty. We just looked at pure median question, standard deviation with some AP and other things thrown in. If 3 terms are in AP, the middle term is the average. If all terms of a set are equal, the standard deviation is 0. Come back to what we have discussed with the earlier questions. Right. Let's look at the next set of questions. Going to be more interesting, a bit more difficult than the ones you have discussed. That should basically bring us to the end of the session. Here are those questions. Start with the first of these. A, B, and C are 3 positive integers given in the question, such that the product ABC equals 12. What you need to find out is the standard deviation of A, B, and C. When is the data sufficient? When you have a unique value. You should be able to say the standard deviation is equal to 8 or the standard deviation is equal to 12. You need to be able to come up with a unique number for it. What are these numbers? They're positive integers. What do we know in the question stem? Their product is equal to 12. Take a minute. Let's see whether you're able to get it. Statement 1 reads, the median of A, B, and C is equal to the range of A, B, and C. And keep track of this information from the question step. How do you start? Product of 3 positive integers is equal to 12. What could that be? Right? Have they said these integers are distinct ones? They have not mentioned that. So numbers could very well be the same. So I'm going to list down some possibilities. 1, 1, 12. The product is equal to a 12. This is one possibility. Second possibility, 1, 2, 6. This is also going to have a product which is 12. Third possibility, 1, 3, 4. This is one more possibility. The product is still at 12. Is there anything else? Have you missed out something? There is, which is essentially 2, 2, and 3. The product of these 3 numbers is also equal to a 12. These are the only 4 possibilities where the product of 3 positive integers is going to be equal to a 12. Let's start listing down the median and the range for each of these and check out in which all cases is a median equal to the range. The median in this case is 1. Range is equal to 11. Is the median equal to the range? It is not equal. So this is not what we are talking about. 1, 2, and 6. Median is equal to 2. The range is equal to 5. Is the median equal to the range? No. This is not what we are talking about. Next one. The median is 3. The range is 4 minus 1, which is also equal to 3. So this is definitely a case we are talking about, a possible set of numbers. The last one, 2, 2, 3. The median is equal to 2. The range is equal to 1. Median is not equal to range. So this is not what we are talking about. So with this information that ABC equals 12, 3 numbers are positive integers, and the data given in statement 1, there is only one set of numbers which will satisfy it. 1, 3, and 4. There is going to be a unique value for the standard deviation of this. At this point, don't make the mistake of actually computing the standard deviation, right? That would be the silliest thing to do. Can you find a unique answer? Yes, you can. That's all that we need here. So statement 1 has given us a unique value. I don't know the value, but I know it is unique. Answer choice is going to be A or D. Let's move on to statement 2. Statement 2 says the median of A, B, and C is less than the range of A, B, and C. You've done a lot of work in the first statement. So let's just quickly run through it. What are the possibilities of A, B, C being integers where the product will be 12? 1, 1, 12 is possibility 1. Second one, 1, 2, 6. Third one is 1, 3, and 4. And the last one is 2, 2, and 3. Need to find out the median as in the last case, and let's find out the range. Here they're saying the median should be less than the range. The median is 1. What is the range? 11. Is the median less than the range? Certainly yes. This could be a possible set. Second one, what is the median? Median is 2. What is the range? 5. Is the median less than the range? Certainly yes. So this could be a possible set. It's quite evident that the standard deviation of the first set of 3 numbers, 1, 1, 12, is going to be different from the standard deviation for the second set, which is 1, 2, 6, pointing to the fact that we're not going to get a unique answer with statement 2. 2 alone is not sufficient. 1 is sufficient. So we can basically rule out choice D and 0 it to E. So statement 1 alone is sufficient as answer to this. Next one. Is B the median of 3 numbers A, B, and C? Right here we have not been asked to find out the value of the median. What we need to figure out is whether B is the median. It's a B verb question, is question. Answer should be a definite yes or a definite no. If you're able to say B is the median, good. If you're able to say that no, it is A or C, I do not know which one, but certainly it is not B. If you're able to say that, that's also good. Right? So evaluate each statement independently. Modulus of A minus B is equal to modulus of B minus C. Little things, let's get clarity. What do you mean by modulus of A minus B? Modulus of A minus B measures the distance between 2 points A and B on a number line, right? Here is A, here is B, right? This could be A and B, or it could be vice versa. It doesn't matter. The distance between A and B is what is measured. What does this state? It essentially says that the distance between A and B is the same as the distance between B and C. What all could be the possibilities? A could be here, B could be here, C could be here, right? This is the distance between A and B distance between B and C, both are same. So quite evidently, we are looking at something which is in an arithmetic progression. Or it could be this way. I do not know which is greater, which is lesser. C could be the smaller number, A could be the larger number, B is the middle number. So if this happens to be the case, whether it is ABC or CBA, the median is B, right? So modulus of A minus B equals modulus of B minus C points to this. Hold on. Did they see these numbers are distinct numbers? They have not mentioned that. So if that's the case, can A be equal to C? For example, let's say A is equal to 5, C is also equal to 5, B is equal to 7. Is the distance between A and B the same as the distance between C and A? In that case, what is going to be the median? It is either going to be A or it's going to be C. It certainly is not going to be B. So what could be the median? Median could be B or median could be one of these two numbers. This will happen when A equals C. If A is not equal to C, B is the median. If A equals to C, B is not the median. So from statement 1, we do not have a unique answer. So watch out for these things. This is the trap in this question. So statement 1 is not sufficient. Rule out choices A and B. What we are down to is B, C, or E. Evaluate statement 2 alone to figure out whether it's B. If not, let's combine and check out. What is statement 2? B is greater than C. Brilliant, right? So we have C here, we have B here, we have A here. What is the median? Median is going to be B. B is greater than C. C is less than B. Can it be this way? You have B is greater than C and A is lesser than this number, right? So ACB could be an order in which these three numbers are placed. In which case, what is going to be the median? The median is going to be equal to C. So we do not know which number is the median. B greater than C could place B in the second position or could place B in the third position. We're absolutely not sure in the ascending order of this. So statement 2 alone is also not sufficient. Let's rule out choice B. What we are down to is C or E. We have information that A minus B, modulus of A minus B is equal to modulus of B minus C, which essentially points to the fact that B is equidistant from A and B, and B is greater than C. We'll just take some examples, counter examples, and finish it off. Right? One case is essentially 1, 3, 5. Right? This is A. This number, keep this as C. This number as B, and this number as A. The difference between B and C is the same as the difference between B and A. What is the median? Is B greater than C? B is certainly greater than C. Right? It satisfies all the conditions, right? And what is the median? Median in this case is equal to B. Let's look at one more example. We can look at this case where B is equal to 3, A and C are equal to 1. Is the difference between B and C 2? Yes. Is the difference between B and A 2? The distances or the differences between AB and BC is the same. So this part holds good. Is B greater than C? Certainly yes. What is going to be the median in this case? The median is 1, which is either A or it is going to be C. So despite combining the two statements, what we end up seeing is the median could be B or the median could be one of the other two numbers. So combining the two statements, we still haven't got a unique answer. So statements together are not sufficient. E is the correct answer. Before we wind up, what if we had as an information in statement 2 instead of this, right? See if you can frame a different statement 2 that will essentially make these statements together sufficient. What information if you had, you would have been able to decide whether B is the median. If you had clarity about what C or A is. If statement 2 either mentioned A equals C or mentioned A is not equal to C, then we would have had a way forward. If A is not equal to C, then this is the scenario we are talking about. In that case, B is the median. We would have got a definite yes as an answer. If A is not equal to C, if A is equal to C, this is the scenario we would have been talking about. In that case, we would have come up with a definite no, B is not the median as an answer. So if this had been statement 2, one of these two, answer choice would have been C. Because this is what we have, answer choice E is the correct answer. Quick takeaway, modulus of the difference between two numbers essentially measures the distance between 2 points A and B on the number line. Towards the end of the session, I'm mightily relieved. I was quite worried. What if there's a power failure? There's an internet failure. Thank God, all went well. So we had another good session. Thank you guys for being a part of it. Before we wind up, what are we going to do next month? Next month, the first Friday falls on December 1st. The same time, 10 p.m. IST. We're going to be asking Shweta to do the session, critical reasoning. It's actually a repeat of the last session. The last time when we did it in the month of September, we had some technical glitches. So we had a feedback from students if we could repeat that session. So that's what is going to happen on December 1, 2017. To stay updated about all of these, bookmark this page. This is a page where I've sent you mails to follow us on with this live classes. Also subscribe to our YouTube channel. Every time I add a new video with questions and updates, you'll have an access to it. Thank you. Thank you all. Thank you for being a part of this session. It's been a wonderful session as always. See you in January when I'll be handling this session. In December, Shweta will walk you through critical reasoning, weakening, and argument. Good night.